Good day, everyone. We are the group 5, and our topics is the normal distribution and its properties, standard application, and the normal approximation to the binomial distribution.
Good day, everyone. I am Renaee Sude. I'm going to discuss is about the normal distribution. Normal distribution, or also known as the Gaussian distribution, is a type of continuous probability distribution for a real-valued random variable. In the graph form, normal distribution will appear as a bell curve, just like this. A normal distribution, sometimes called the bell curve, is a distribution that occurs naturally in many situations. For example, the bell curve is seen in the test like in the NAT test. The majority of the student will score the average of C, while the smaller number of students will score of B or D, and an even smaller percent of students score an F or an A. This creates distribution that resemble a bell. The bell curve is symmetrical. Half of the data will fall to the left of the mean, half will fall to the right. Many groups follow this type of pattern. That's why it is widely used in business, statistics, and in government bodies just like FDA, where they can measure the height of people, measurement of error, a blood pressure, points on a test, IQ score, or a salary. So for the next reporter, may I call Miss Shaina Mae, Macapillar.
Thank you for that, Miss Sude. Properties of normal distribution. So here are the properties. Number 1 is the distribution is dapat naka-bell shape and the curve is symmetrical with respect to the vertical axis. Number 2, the mean, median, and mode are equal at dito siya nakalocate. And it's divided the normal curve into 2, which is each part merong 50%. Number 3, asymptotic with respect to the horizontal axis. Meaning, the normal curve is asymptotic to the horizontal axis. So, palapit ng palapit, but it never touches the horizontal axis. Number 4 is the total area under the curve is 1 or 100%. Number 5, the width of the curve is determined by the standard deviation of the distribution. Okay, so now let's talk about the empirical rule, also known as the 3 sigma rule or the 68-95-99.7 rule. It is a statistical rule which states that for a normal distribution, almost all observed data will fall within 3 standard deviations from the mean, which means 68% of all datasets falls within 1 standard deviation, mu plus minus 1 sigma from the mean. 95% of all dataset falls within 2 standard deviation, mu plus minus 2 sigma from the mean. And 99.7% of all dataset falls within 3 standard deviation, mu plus minus 3 sigma from the mean. So, kung matatanong ninyo kung bakit 99.7% lang and where is the 0.3%. So, the 0.3% is what we call the outliers. Ito, highlight ko. Take note of that. And now, let me show you the empirical rule in bell curve. So, ito yung bell curve or shape. And the middle line is the mean. And the symbol is mu. And this area is 1 standard deviation from the mean. So we have mu minus 1 on the left and mu plus 1 on to the right. And this contains 68% on the bell curve divided by 2. So each shaded ng 34%. And itong area naman na ito is the second or the two standard deviations. So we have here the mu minus 2 and mu plus 2. And after here, we have 95%. So 95 minus 68% is equal to 27. Then divide 2 is equal to 13.5%. For the last 3 standard deviation, mu plus 3 and mu minus 3. So from here to after here is 99.7% of the bell curve, and 99.7% minus 95% is 4.7 divided by 2 is equal to 2.35. So now, let's illustrate the empirical rule. Let's answer this given question. So the average IQ score is 100 with a standard deviation of 15. So the mean is the average and it's 100. So we have here the bell curve and standard deviation is 15. So from the mean going to the right, i-add lang natin yung 15. So 100 plus 15 is equal to 115. Plus 15 is equal to 130. Then plus 15 is equal to 145. And dito sa left, ima-minus natin. So 100 minus 15 is equal to 85. Minus 15, 70. Minus 15, 55. So the question is, what scores falls within 68% of the distribution? So, ito yung 68% and scores from 85 to 115. So, the answer is 85 to 115. Number 2 question is, what score falls within 95% of the distribution? So, the score is from 70 up to 130. So, the answer is 70 to 130. Number 3, what scores falls within 99.7% of the distribution? So, simula dito hanggang dito, ang scores will be 55 to 145. And that's the answer na. Okay, another example. The average of senior high school students in your class is normally distributed with a mean of 84 and standard deviation of 3. Okay, the mean is 84 and standard deviation is 3. So, we have here the bell shape. So, same lang din kanina yung paano i-solve. So, ngayon, yung mean natin is 84. Then, standard deviation is 3. So, dito, ipag-add lang natin ulit. 84 plus 3 is equal to 87. Plus 3 equals 90. Plus 3 equals to 93. And from the mean, going to the left, and isasubtract natin. So, 84 minus 3 is 81. Minus 3 is 78. Minus 3 is 75. So, the question is, what average grade falls within 68% of the distribution? So, 68% is the first standard deviation from the mean. So, lahat ng nasakop dito, that is 81 to 87. And that's the answer. Number 2 question, if your average grade is 90, how many standard deviation are you away from the mean? So, the average grade is 90 and ito ay nasa 2 standard deviation. So, from the mean, the answer is 2 standard deviation higher than the mean. Number 3 is, what percent of the average are between 78 to 87? 78 to 87. So, what percent and Para makuha ang answer, i-add lang natin yung percentage ng nasasakop. So, 34 plus 13.5% is equal to 81.5%. And that's the answer.
Good day everyone, my name is Shaina Mae and we were talking about the standard normal distribution.
The standard normal distribution, also called the Z distribution, is a special normal distribution where the mean is 0 and the standard deviation is 1. Any normal distribution can be standardized by converting its values into the Z-scores. Z-scores tell you how many standard deviation from the mean each value lies. Converting a normal distribution into a Z distribution allows you to calculate the probability of the certain values occurring and to compare different datasets. How to calculate a Z-score? To standardize a value from a normal distribution, convert the individual value into a Z-score. One is subtract the mean from your individual value. Second, divide the difference by the standard deviation. Okay? So, Z stands for Z-score. X is individual value. U is mean. And standard deviation. Next is example, finding a Z-score. You collect such scores from students in a new test preparation course. The data follows a normal distribution with a mean score of 1,150 and is the standard deviation of 150. You want to find the probability that such scores in your sample exceed 1,380. So, to standardize your data, you first find the Z-score for 1,380. The Z-score tells you how many standard deviations away 1,380 is from the mean. So, we have a two-step. First step is subtract the mean from the X value. So, yung X natin is individual value, which is 1,380, and yung M natin is mean score, which is 1,150. So, ang gagawin po natin dyan is yung individual value and yung mean score is isa-subtract natin siya na 1,380 minus 1,150 is equal to 230. And step 2 is divide the difference by the standard deviation. So, yung standard deviation natin is 150. So, yung nakuha natin dito sa Z-score is 230. Ang gagawin lang natin is 230 divide 150. So, 150 is equal to 1.53. So, nakuha na natin yung sagot sa standard deviation. So, the Z-score for a value of 1,380 is 1.53. That means 1,380 is 1.53 standard deviation from the mean of your distribution.
So, ang focus po natin ay kung paano natin kunin yung areas under the normal distribution. So, para po makuha natin yung areas under normal distribution, we can use these tables. So, marami po tayong makikita sa internet nito. Pwede nyo po ito i-download. So, paano po ba gamitin ito para kunin yung corresponding areas ng Z values natin? So, ito pong nasa left side, itong first column na ito, that is the Z values. And yung nasa taas naman po, that is the hundreds place of a Z values. Ito po yun. So, paano po ba natin to gamitin? Four-step process. Una, express the given Z value into a 3-digit form. Pangalawa, using the Z table and find the first 2 digits on the left column. Pangatlo, match the third digit with the appropriate column on the right. Pang-apat, read the area or probability at the intersection of the row and column. Find the area that corresponds to z equals to 2. So, yung z equal to 2, so parehas lang siya kapag nakita nyo yung between z equal to 0 and z equals to 2 or using the interval notation, yung z niya is greater than 0. But a less than 2 that should be greater than or equal. Okay, so between 0 and 2, titignan muna natin saan ba natin nakikita yung 2. So, tingin tayo dito sa left side. Dito sa first column natin. So, 2.0, 2.1, 2.2, since wala tayong kasamang decimal, yung 2 natin, so yung 2.0 yung kukunin natin. So, therefore, 2.0 plus, since walang kasamang decimal, so 0.00 yan. Itatapat natin sa 0.00, so plus 0.00, therefore, ang intersection nito, that is 0.4772. So, yan yung area correspond to z is equal to 2. Therefore, ang area nito ay 0.772. So, pag titignan natin sa graph yan, ganito po. Ito po yung graph. Mula 0, between 0 and 2. So, ito po kapag shinade natin, the normal distribution, okay, so ito yung shading portion, yan yung 0.4772. And we have another example. Find the area that corresponds to z equal to 2.47. So, ano yung area ng 2.47? So, una, tingnan natin yung whole number tsaka yung temp place natin. Ito yung 2.4. Etong dalawang ito, and then hanapin natin dito sa first column sa left side. So, makita natin yung 2.4 natin. Okay? So, yung 2.4 din, hanapin natin yung 7. So, yung 7 natin, that is 0.07. So, dun sa taas, hanapin natin yung 0.07. So, yung intersection nila, which is 0.4932, yan ay correspond sa z equal to 2.47. So, ganito ang paggamit ng tables o ang pagkuha ng areas ng normal distribution gamit yung tables na ito. Paano naman kung ang given natin ay negative? Halimbawa, negative 2.47. So, ang sagot pa rin po doon ay positive. Sabi nga po sa properties, since symmetrical sila, so kung negative 2.47 yan, ang sagot pa rin po ay 0.4932. Okay po, so ito po yung graph natin. So, ito po yung graph natin.
Application of normal distribution formula. C equals X, or where the value of any particular observation minus mu, or population mean, over sigma, or the population standard deviation. So, okay, example number 1. The average pag-ibig salary loan for RFS pharmacy employees is 23,000 pesos. If the debt is normally distributed with a standard deviation of 2,500, find the probability that the employees owes less than 18,500. So, first na gagawin natin, hahanapin natin yung given. So, mu is 23,000 or the average. Sigma or the standard deviation of 2,500. And the x is 18,500. Kasi yung question, find the probability that the employees owes less than 18,500. So, okay. Let's go to step 1. Step 1. Draw a figure and I represent the data. So, magdodrawing tayo ng normal distribution curve. Ayan. So, tapos, magdodrawing tayo ng line. Dahil itong line na to, itong gitna na to, ito yung mean, or kasi si mean yung highest point ng lahat ng value. So, ilalagay natin mu is equals 23,500. So, yung hinahanap natin, si x, 18,500 or yung probability. So, pwede natin sabihin na nandito siya. Yan. Ayan siya, si x. So, ilalagay natin dito, 18,500. Less than yung hinahanap, less than. So, less than. So, kasi, sa normal distribution curve, ito, dito left, itong left na to, ito yung negative values, and dito, sa right, ito yung positive values. So, pwede natin sabihin na andito si 18,500. Ayan. So, pagtapos natin i-value si 18,500 sa curve, isi-shade natin. Shade. So, ayan. Ito na yung represent dito. So, isusulat natin dito. Or, ayan na yung C-score. P over C less than 18,500. So, ito na yung figure at saka yung represent data niya. So, okay. Step 2, find the C value for 18,500. So, where C is equals to X or ating 18,500 minus mu or yung 23,500 yung average over sigma or yung standard deviation 2,500. So, 18,500 minus 23,000 divided by 2,500. So, dito kahit anong calculator pwede gamitin, cellphone or scientific, pwede. So, ito na yung calculator. So, 18,500 minus 23,000 equals 4,500 divided by 2,500. Ang nakuha natin ay negative equals negative 1.8 or pwede natin siyang gawing 1.80. So, ito yung step 2 natin. So, C, 18,500 minus 23,000 or yung mu over 2,500 or divided by 2,500 equals to 1.80. So, proceed na tayo sa step 3 natin. Find the appropriate area. So, yung C-score na nakuha natin kanina, C-score is negative 1.80. So, dito natin gagamitin yung standard normal distribution na table. So, ito yon yung standard normal distribution na table. So, yung nakuha natin kaninang C-score is 1.80. So, dito, hahanapin natin yung 1.8. And so, sa taas, dahil 1.80 siya, so, may 0 doon. Ang hahanapin natin ay 0.0. So, 1.8 and 0.0. Itong makuha natin value, 0.4641. So, using the table kanina, yung value ng negative 1.80 is 0.4641. Dito tayo sa ating step 4. So, yung nakuha natin sa table kanina, yung 0.4641 ay isusubtract natin sa 0.5000. Bakit siya 0.5000? Dahil kung babalikan natin yung table natin kanina, andito lang naman si 18,500. So, etong nakashade na to, ito yung 0.4641 dahil itong parehas na side na to ay 0.5000 yung value nila. So, itong side na to ay 0.5000 yung value nila. So, yung magiging final solution natin ay ganito. 0.5000 minus 4641. So, kuha ulit tayo ng calculator. So, ito na yung calculator natin. So, 0.5000 minus 0.4641. Ang sagot ay 0.0359 or ito yung decimal point, magiging dito yung decimal point, 3.59%. So, magiging ito yung value natin. So, magiging ito yung value natin or ang final solution natin. Ating last step, ang ating conclusion. So kung babalikan natin yung question kanina, yung find the probability that the employee owes less than 18,500. Therefore, yung nakuha natin is 3.59%. So pwede nating sabihin na the probability that the employees owes less than 18,500 is 3.59%. Application of normal distribution. So, dito may 5 steps siya. So, step 1, draw a figure and represent data. So, dito gagamit tayo ng normal distribution na curve. Step 2, find the C value. So, dito i-apply natin yung formula na ang formula ay C equals X minus mu over sigma. Ang ating step 3, find the appropriate area. So, dito gagamit na natin yung table na normal distribution table para malaman natin kung ano yung C-score. And step 4, subtract kung ano yung makukuha natin sa table from 0.5,000. And the last, the conclusion.
Hi guys, my name is Rachell, Lyka, Enpictana, and my topic is all about normal approximation to the binomial distribution. The normal approximation to that binomial is when you use a continuous distribution, the normal distribution, to approximate a discrete distribution, the normal distribution. According to the central limit theorem, the sampling distribution of the sample means becomes approximately normal if the sample size is large enough. The first step into using the normal approximation to the binomial is making sure you have a large enough sample. How large enough is? Large enough, you figure this out with two calculations, n multiplied by p and n multiplied by q. N is your sample size, p is your given probability, q is just 1 minus p. For example, let's say your probability p is 0.6. You will find q by subtracting this probability from 1. Q minus 1 minus 0.6 equals 0.4 percentages. Instead of decimals, can make this a little more understandable. If you have a 60% chance for it raining P, then there's a 40% probability it won't rain Q. When n multiplied by P and n multiplied by Q are greater than 5, you can use the normal approximation to the binomial to solve a problem.
This is Stephanie from statisticshowto.com, and in this video I'm going to show you an example of working a continuity correction factor problem. I have a sample problem here. I've got n equals 20, p, that's the probability, is 0.25. What's the probability is x is greater than or equal to 8? Well, the first thing I want to do is figure out n times p. So n times p, I've got n is 20 and p is 0.25. So 20 times 0.25 equals 5. And I also want to figure out n times q. Q is just 1 minus p. Well, if my p is 0.25, then my q is 0.75. So n times q is going to be 20 times 0.75. That equals 15. Now the continuity correction factor says that if n times p and n times q are over 5, then we can use the continuity correction. Well, these are both over 5. This right here is also the mean of a binomial probability distribution, n times p. We're going to need that in another step, so I'll just make a note of that. Next, I want to figure out the variance. The variance of a binomial distribution is n times p times q. My n is 20 and p is 0.25. and Q is 0.75. And if I multiply this through, I get 3.75. So this is my variance. Next, I want to actually use the continuity correction factor. I'm going to consult a chart. You can find this table on our website, statisticshowto.com. What I'm looking for here is the probability that x is greater than or equal to 8. So if I look here, the probability that x is greater or equal to a number, then I'm going to subtract. With continuity correction, you're either subtracting or adding. In this case, I want to subtract. So I need to subtract 0.5 from my x value. My x value is greater than or equal to 8. So instead of 8, I'm going to have 7.5. So 8 minus 0.5 is 7.5. I'm going to use this in finding the z value. If you're not very familiar with finding z values, you can check out our other video. The formula is z equals x minus the mean, x bar, all over the standard deviation. My x is now 7.5 because I used that continuity correction factor, 7.5, minus the mean, which we figured up here as being 5. And this is going to be all over the standard deviation, which is the square root of variance. So I'm going to use the variance we found here, 3.75, and take the square root. And if I figure this out on the calculator, I get 1.29. This is my z-score. I'm going to look up this z-score in the z-table. 1.29 gives us an area of 0.9015. My area was 0.9015. Not quite done yet. That's because I need to subtract from 1. The z-score here is going to give us the value left of this point, which was 1.29. What we want is this area here, so we're going to need to subtract the score from 1. 1 minus 0.9015 is equal to 0.0985. And this is the area right of that z-score, and this is our probability for x is greater than or equal to 8. Check us out at statisticshowto.com for more examples and videos on everything elementary statistics.
Example, 62% of 12th grades attend school in a particular urban school district. If a sample of 512 12th grade children are selected, if the probability that at least 290 are actually enrolled in school. Part 1. Making the calculation. Step 1. Find P, Q, and N. The probability P is given in the question as 62% or 0.62. To find Q, subtract 3 from 1:1, subtract 0.62 equals 0.30. Sample size N is given in the question as 500. Step 2. Figure out if you can use the normal approximation to the binomial if n multiplied by p and n multiplied by q are greater than 5. Then you can use the approximation n multiplied by p equals 310 and n multiplied by q equals 190. These are both larger than 5, so you can use the normal approximation to the binomial from this question. Step 3. Find the mean by multiplying n and p. N multiplied by p equals 310. You actually figured that out in step 2. Step 4. Multiplying step 3 by q. 310 multiply 0.38 equals 117.8. Step 5. Take the square root of step 4 to get the standard deviation. Square root quantity 117.8 equals 10.80. Part 2. Using the continually correction factor. Step 6. Write the problem using correction notation. The question stated that we need to find the probability that at least 290 are actually enrolled in school. Px greater than to equal to 290. Step 7. We write the problem using the continually correction factor. Px greater than to equal to 290 minus 0.5 equals Px greater than to equal to 289.5. Step 8. Draw a diagram with the mean in the center. Shade the area that corresponds to the probability you are looking for. We're looking for x greater than or equal to 289.5. Graph using continually correction factor. Step 9. Find the z-score. You can find this by subtracting the mean from the probability you found in step 7, then dividing by the standard deviation. Quantity 289.5 minus 310 divided by 10.85 equals negative 189. Step 10. Looking up the z-value in the z-table. The area for negative 189 is 0.4706. Step 11. Add 5 to your answer in the step 10 to find the total area featured. 0.4706 plus 0.5 equals 0.9706 or 97.06%.